I believe Model Context Protocol represents the most significant breakthrough in AI architecture since the Transformer. After watching countless developers struggle with brittle integrations and one-off solutions, MCP finally gives us what we have desperately needed: a universal interface that lets AI models interact with tools, data, and external systems in a consistent, scalable way. Think of it as the USB-C of artificial intelligence. Before USB-C, every device needed its own proprietary connector. Chaos. MCP solves the same problem for AI applications. Once something speaks MCP, your agent can use it without custom instructions or fragile workarounds. Here's what actually works in practice. I recently consulted with a healthcare startup drowning in patient data analysis. Their team of 5 doctors was burning 20 hours weekly on routine scan reviews. We brought in an AI engineer who built an MCP-powered machine learning system for preliminary analysis. Those 20 hours dropped to 3, accuracy improved by 28%. The doctors could focus on complex cases that genuinely required human expertise. But here's the real breakthrough. This wasn't happening in isolation. The same AI engineer had been a web developer just 18 months earlier. She learned Python and TensorFlow, mastered the MCP architecture, and suddenly possessed capabilities that felt like superpowers. MCP operates on a clean client-server model. Your MCP host runs the AI model. The client sends requests. The server provides tools, resources, and context. When your model needs external help, web searches, calculations, database queries, it communicates through MCP protocols. The server handles execution and returns formatted results the model can understand. Security is baked into the foundation. Every tool call requires user approval. Authentication and rate limiting protect against abuse. Users maintain complete control over what gets shared, executed, or exposed to their models. This isn't an afterthought. It's fundamental architecture. The practical applications are staggering. I worked with a manufacturing company spending $300,000 annually on legacy infrastructure. Our cloud architect designed an MCP integrated hybrid solution that cut costs by 40% while boosting performance by 60%. The system automatically scaled resources based on demand, eliminated downtime during traffic spikes, and reduced cloud spending by 25%. So what separates successful MCP implementations from mediocre ones? Understanding that technical skills are just the foundation. The magic happens when you can translate between machine efficiency and human needs. I've seen retail systems increase sales by 35%, not because they had superior algorithms, but because the engineer understood customer psychology before designing the recommendation system. The salary data tells a compelling story. AI engineers command up to $180,000 in the US market. Cybersecurity specialists with MCP expertise routinely negotiate packages exceeding $165,000, but focusing solely on compensation misses the deeper opportunity, the chance to create work that genuinely matters. I've observed a pattern among the most successful professionals in this space. They cultivate deep specialization while maintaining broad awareness. The cybersecurity expert who understands machine learning principles spots threats that slip past traditional defenses. The cloud architect who grasps business strategy designs systems that solve real problems rather than showcasing technical elegance. Now look, this transition isn't simple. Every professional I've guided through MCP adoption has faced moments of doubt. Learning new frameworks feels disorienting. Developing fresh mental models requires patience. But those who persist discover something remarkable. The market rewards this persistence with extraordinary opportunities. The future belongs to professionals who understand that AI isn't replacing human creativity, it's amplifying it. Manufacturing operations now prevent equipment failures before they happen. saving millions in downtime costs. Smart farming systems reduce water usage by 40% while increasing crop yields by 25%. These aren't isolated successes. They're examples of what becomes possible when you position yourself at the intersection of AI capabilities and human insight. The technical foundations matter enormously. Python, TensorFlow, cloud architecture principles, and cybersecurity fundamentals form the bedrock. Yet technical skills alone won't unlock the opportunities I'm describing. The transformation happens when you develop the uniquely human capacities for empathy, ethical judgment, and creative synthesis that turn technical competence into genuine innovation. Start with the fundamentals. Master Python and data analysis principles. Build specialized expertise in one domain while maintaining awareness across adjacent fields. Most importantly, cultivate the ability to stand in the gap between what machines do exceptionally well and what remains uniquely human. The extraordinary opportunities I've described aren't reserved for others. They're waiting for professionals who understand that MCP isn't just a protocol, it's the foundation for building the next generation of intelligent systems. The question isn't whether this transformation will happen. The question is whether you will be part of creating it.